G'day, Brenton here, VK2MEV. This is the demo video that's going to show a bunch of the features of my homebrew DSP. Basically, I've implemented a lot of different control features since my last videos. There's a few things controlled by these four potentiometers on the left and a couple by these two jumpers here. Basically, the controls we've got, firstly, there's three controls for the compression algorithm. The one in the top left here controls how fast the compressor releases. The one in the top right controls how much gain the compressor is allowed to use to help and maintain a constant level out. The one in the bottom left controls the gate. Now you can think of this basically as a squelch level. Essentially, you set the gate level so that below a certain input volume, the output is completely attenuated. But we'll show a demo of that later. And the bottom right control here is a filter cutoff selection. So what I've managed to do is program 64 different digital filters into this chip. They're just in a large memory array. Just the filter coefficients if you're a DSP guru. And basically, just by twiddling this knob, we can control where the high-pass filter cuts off. So these two on the right here control the filtering in more advanced ways. The one on the right is fairly simple. That one controls whether the filter's on or not at all, so it's basically just a filter bypass jumper. And the one on the left controls the filter order, so it can be a second order filter or a third order filter. And the advantages and disadvantages of which order of filter you choose we'll go into later. Okay, so in Audacity here, I've got several test tracks that I'm going to use to test the various features. The first one to test is the compression, and to do that I've got this middle track here. What this is a 440 Hz sine wave that has this linear dB ramp on it. If you look at it in a linear, with a linear vertical axis, you'll see this exponential growth. That's equivalent to a linear dB ramp. So if we hit record on that, what will happen is Audacity will play that track, and I'm recording back the output from my processor. And as you can see, both in Audacity and on the VU meters on the DSP, both the input and output are going up and down basically the same. The output on the DSP drops slightly slower than the input level, but that's by program. The rate at which this output meter drops is constant, whereas this one, this is an envelope follower on the input, and that's actually variable. Anyway, it's currently set to release quite fast, but what I can do is get in here with a screwdriver and vary this knob here. This is going to vary the amount of gain that the compressor is allowed to use. So I'll just turn that up a little bit, and you can see now that the output is getting to full scale before the input. And if we look back on Audacity, you'll notice, if we just stop the recording there, you'll notice that the output signal from the DSP is actually reaching full scale and sitting there. So what's happening is the compressor is looking at this incoming envelope and saying, oh, okay, well, this is below full scale here, so we can amplify that a bit, and the level of amplification is set by the potentiometer on the board. And then when the output gets to full scale, it stops amplifying it, and it's programmed so that it maintains a full scale output. Okay, and you'll see there's not a great deal of distortion. There will be a little bit of distortion on that waveform because the envelope follower was set very, very rapid, and so as the sine wave drops off on the far side, it will actually try to amplify that a little bit, but that's all adjustable, so that doesn't happen. Okay, so there's the compression level being demonstrated. The next thing I can demonstrate is the gating. If we look at this in dB and put the input trace in dB as well, you'll see when it's very quiet, it looks a little bit wobbly. And if we zoom in on that, it looks pretty rubbish. And that's basically because there's a whole stack of 50 Hz noise that's getting into the breadboard in the analog amplifier section. and that's just causing this distortion down here. So let's say we wanted to get rid of that. Say we just want to get rid of the output noise. Well, what I'll do for demonstration purposes is wind up the gain on the compressor all the way. So on the output VU meter here, we can see that we're basically just amplifying noise. I'm not playing anything in Audacity at the moment. And from here, we can set the gate level. And so what the gate level does is if I wind this potentiometer up a bit, and there it goes. When it's all the way down, it's just allowing any signal to come straight through. And if I wind it up a little bit, that says, okay, if a signal is below a certain level, we just completely attenuate it. Okay, I was trying to demonstrate the gating function, and for quite a long time I couldn't work out why it was working. And it turned out that this potentiometer here was in fact faulty. So I've installed a new potentiometer here, and I'll hopefully demonstrate the gate level adjustment. So in Audacity, I've got the same compression ramp test track playing, and you can see there is some compression currently active. But you can also see that below a certain input volume, the output is completely attenuated, and that's completely adjustable with the gate level potentiometer here. If I wind it all the way down, it will simply let through any volume level, so there's no cutoff when there's a low volume. In other words, it's like having the squelch all the way open on your radio, and if I turn it all the way up, you'll see on the recorded waveform that the input volume actually has to get quite loud before the output opens at all. And you'll also notice the same thing happening on the output VU meter. Okay, so we'll just turn that all the way down. What I might just do is create a new test track to demonstrate the compression release adjustment. Okay, so what I've generated here is a thing called a click track. It's just these little sinusoidal pulses. And what I'm going to demonstrate now is the compression release time. So if I just get that started, you'll see that the pulses are being seen here on the input VU meter. And what I can adjust is what's called the release time. So it's currently fairly fast. The control knob here goes down to a release time of about 1 millisecond, which is incredibly fast. And if I wind this all the way up, you can see it's starting to release a little bit slower, and at maximum it releases at about 2 seconds or something like that. But the click track's a little bit fast, so I'll wind that down. So essentially this can just allow how much waveform shaping that the DSP is going to do to your voice. So if you set it to really, really fast, your voice is just going to be shaped so the whole thing is just this complete block of sound. Whereas if you make it quite slow, you maintain a lot of the natural volume changes in your voice, and you sound a little bit quieter, but also a lot more natural. So that's the adjustment of the compression release time. Okay, the final demonstration I'm going to do is of the filtering. So I need to do a couple of things. First thing first is remove this jumper, and that turns the filter on. And I'll twiddle this knob all the way maximum. So that sets the filter cutoff to 1 kilohertz. The range that I've programmed on this adjustment here is 100 hertz to 1 kilohertz. So what I'll do in Audacity now is unmute the noise track and record a little bit of the noise track. Okay, that's a bit of noise. The other thing is I've got this jumper here on, and that sets a second order filter when that's connected. So if we go to Audacity, select our noise and look at the spectrum here, we can see this really sharp cutoff from about around 1 kilohertz. Okay, that's all well and good, but how about adjusting it? So let's set our noise recording, and while it's recording, I'll actually turn the knob that adjusts the cutoff frequency. Just drop that slowly. Okay, and then we can go back into Audacity and look at the spectrum of the recording I just took. Look at the spectrogram here and make it a little bit bigger and enhance the lower frequency spectrum. And what you'll see here is we started off with a cutoff frequency of about 1 kilohertz, which is just off the plot there, and it's slowly ramping down here. So we're just getting more and more bass there. So that's just adjusting the cutoff frequency as it records. The final thing is to compare a second order filter to a third order filter. So I'll just adjust the frequency cutoff all the way up to 1 kilohertz again, and just record a few seconds in Audacity for our second order filter sample. And I'll stop that, disable the filter, and pull this knob off, that jumper off, and that enables the third order filters, and then turn the filters back on again. You have to disable them before changing between second or third order filters, otherwise the filters become numerically unstable and you just get a whole stack of noise. Anyway, we'll go into Audacity and record a little bit more of our filtered noise. That should be enough there. Now I'll bring up the spectrograms for both of these recordings. Okay, now you'll see this is showing a fairly zoomed in section. Oh, sorry, the sort of the bottom 1 kilohertz. But you can see that the second order filter, which was this first recording, is allowing a lot more low frequency sound through than our third order filter. If we just bring up the frequency spectrum of our second order filter, you can see this goes below scale, somewhere between 60 and 100 hertz. And then if we compare that to the spectrum of our third order filter, whoa, you can see that's a lot steeper. The second order filter was going below scale between 60 and 100 hertz, and this one's now going below scale all the way up at 300. So yeah, that's just the power difference between a second order and a third order filter. Okay, so we've seen that the third order filters give us a much steeper cutoff, but it does come at a price. Let's just go back to our second order filter and then enable the filters again, and in Audacity we'll take a recording. Now I have set this to a cutoff of 100 hertz. So just for the record there, this is an effect that happens when you're trying to have a cutoff frequency that's quite low. So with the second order filter, we've got this output noise level at about 4 LEDs. I'll just disable the filter, go over to the third order filter, and then enable it again, and whoa, you can see the noise level here has come right up. And if I do another recording in Audacity, just of our third order filter noise floor, you'll see that, well, even just on the waveforms here, you can see the waveform is much higher for our third order filter. If we plot that spectrum, you see we've got all this really significant noise below the cutoff frequency. So our cutoff here is 100 hertz, and below that there's a whole stack of numerical noise. If we just compare that to our second order filter, there's still some numerical noise there, but it's a lot lower. But this is really only a problem at low frequencies. If we do exactly the same comparison at 1 kilohertz, we'll just wind that frequency right up there to 1 kilohertz. And in Audacity, we'll record about 5 seconds of noise from our 1 kilohertz third order filter, and then disable the filter so it doesn't become unstable. Go over to second order, then enable the filter again. You'll see firstly the noise floors aren't all that much different. And if we sit in Audacity and record about 5 seconds of noise from our second order filter, you can see that their waveforms are not all that much different. So if we look at the spectrum of the third order filter, we don't have that significant amount of low frequency noise. And so the third order filter does give you the steep cutoff, but it comes at the price of more numerical noise, but it's only a problem when you're trying to do a low frequency cutoff. So what I've got here is both of those controls, so you can sort of pick and choose to sort of match what you're trying to do. If you're wanting a filter that's cutting off at 500 hertz, the third order filter is going to be fine. If you want it at 100 hertz, you're going to have to put up with some noise. Anyway, hopefully that's been interesting, seeing all the different features of my DSP. I'm going to be doing a printed circuit board, and if you're interested in building one, hopefully I'll be able to release enough information, or maybe even a kit if you're really lucky. So yeah, this has been Brenton, VK2MEV. Thanks for watching.